Okay, hi guys. Yeah, welcome to this new session, and let's begin to start about to talk about find and signal, right? So find, what is this Unix command find? Then find is something what you do is you find or locate the files somewhere in a Unix file system, and the basic syntax for find is it consists of three important criteria that are where to look for the file that you are looking for, or what is the criteria, what criteria do you have you decided to look for that file. Is it a text file, or is it a something like a C files, or what kind of files is it, like PHP files, or what kind of file is it. So what to do with the file, what kind of execution commands that you have decided to do with the file. So this is the file find the command, and it follows with some kind of criteria, such like this three basic parameters, okay, that you have to specify. And we can search for any set of directories, whatever you specify for the files that match with this supplied search criteria. uh, the found file will be displayed. Alright, so you can search for any kind of files based on the permission, date, criteria, name, honor, okay, the group type, anything. So here is the basic example. I'll just show you the basic example of here. But first let's go to the manual of find. Yeah, it search for the files in the directory hierarchy. So the description is provided here, options. Here lots of options. So I strongly suggest you guys to go through these options, okay, by your own. So uh, I was just planning to give you some example here. Okay, so let's find the file from a root directory. Where to find? From the root directory. Then uh, the criteria was the name must be a text file, and what to do, print. Okay, yes, it printed out all the path of the file names that are the text, right, starting from the home directory, right, and some has some permission denied. So this was the example. Now about the max depth. This is the max depth is one of the important concepts that you guys have to understand, because it's mostly related with starting from your home directory. For example, if I change my directory to desktop, this is my depth is 1. That means depth means the level. Okay, starting from home, if I change 1, like if I go inside a subdirectory that is desktop, this is level 1. So if I inside the desktop, we check out, if I go to, there are so many directories, subdirectories, right? Okay, so if I go to one of the directories, that is OS, then this is in level 2, right? Alright, so this was all about the depth. So you can also find according to the depth, like you can specify the criteria where it can search from the current home directory, current working directory. And as I have told you guys that what to do is actually it's the execution part. So this exec option is used to execute the commands, okay, on the find command. So you can also use some operators like and or not, some logical operators. Alright, so here about what is the signal, then what are the Unix signals that I was talking about. Like find was the first part, first command. Now the signal is something that is an asynchronous notification sent to a process in order to notify it of an event that occurred. So it is mostly used for synchronization of the processes. So it's for process synchronization. So you send the just like previously we did process synchronization by using wait system call, right? So signal is something like a wait, but it works in a different way. That is, it works by sending a signal, and it helps in synchronizing the processes. So what happens when a signal is sent is like the operating system interrupts the target processes normal flow of execution. Okay, so the target process flow of execution, okay, is interrupted. And so how do we send the signals then? You can send the signals in two ways. One is sending the signal by using this command, that is kill command, kill1 command. We send the signals directly to the processes, whereas there are kill2 commands or kill2 system calls, which helps us to send the signal to the specific process, that is specific signal to the specific processes, okay, if the permission allows. So how do you wait for this kind of signals then? You can wait for this kind of signals that you send by using a system call that is called pause. So let's go to the manual of pause. Yeah, it waits for the signal, and it's included in a standard error file of Unix. So how do we handle the signals then? We can handle the signals by using a signal handler, right? So there are already default signal handlers, but you can also create your own signal handler, and that we will do. I will show you how to create your own signal handler to handle the signals, to synchronize the processes, right? So, and this is it for the conceptual part of this find and signal. So let's begin the practical part, that is like solve the exercises of this particular topic. So here what you have to do is you have to print the content of all the directories named bin starting from the root directory. So here what you are doing is you are working with find. So let's use this find to find the content and print it out, and with the criteria that is it must be a directory, and the name must be a binary bin, and you find it from the root directory. So find it from the root directory, and the name must be something like it's a bin, and the type must be a directory. So what you do is you print the contents. So you print the contents. So you have to execute and say that ls to display the contents, and you display in such a way and finally you terminate, okay, by using this termination correct. Okay, you guys can check out the situations, right? It's just displaying the contents. Look, each time is displaying the total 200, 2556, right? Something like this. The ls command was executed. Alright, so let's stop, okay, and I will try to explain the manual of if you go and to the manual of the find, and if you check the situation, about exec, okay, yes, this exec, you are trying to execute a command, and that is terminated by the semicolon. And what you guys have to understand is like you cannot directly terminate while using it as a command, because this might create error. Okay, so the so what you have to do is you have to just escape it by using a black slash to escape this semicolon, the termination character. And what it does is just execute the command until all the commands until this semicolon is reached or encountered. And the string with a bracket that I used before is replaced by the current files that the find system called found. Alright, and you guys can just, for your information, you can guys can just check out this documentation and you'll find all the required information. Okay, now let's check out this, how to search for all the .c files belonging to other users then. So okay, first clear this. You find the root directory, all the file names, the names must be a C file, right? So belonging to other users, that means, so you say not user, so this is me. Alright, so okay, it's not. Alright, so this is not me. Okay, all the C files here, if you go and check out all the C files, these are not for me. Okay, so these are, it doesn't belongs to me, but it belongs to other users. Alright, all the C files. So yes, let's terminate this, and let's you guys know that to terminate the like the foreground process, you can just use the keystroke, that is Control C, Control plus C, right? And now let's search for, okay, now let's print the path name of all the files which size is greater than the 100 bytes then. Okay, first you find type is a file, and the size must be plus 100 bytes, so it's greater than 100 bytes, all the size is greater than 100 bytes. Okay, so let's print the path name then. We can print the path name, but I will just try to display you also the situation, that it will list in a human readable form. So all the size of this file will be in human readable form, so like it will be like kilobytes or megabytes or gigabytes, it will be displayed. So let's terminate this command. So for each file that it finds, will execute this command. Okay, this means for each file that it finds, terminate, so it goes through a loop. Okay, so here I just missed one situation, that was this one. now let's see, check the situation. Right, so okay, I will just show you whenever it terminates. Not a glitch. If you want all the size are indicated for previously the size were not in human readable form. Okay, so 50, 65 kilobyte, these are all greater than 2.1 mega or greater than 10 100 bytes, right? So this will display. Okay, now what you have to do is you have to modify all the permission of the files in your home directory so that all the users and other than you have no permission. So you guys know that you have to go to the home directory, so you have to go to find in this like some sign, that is tilde sign. So, alright, so when you go here in this tilde sign, okay, so what you have to do is like you go here, okay, then you have to change the mode, so you have to execute, you go to this location, that is your home directory, so you just change the permission, then it must be it must be a file, so just type is a file and you just change the permission, so you have to execute change mode, okay, like change for groups, that you just remove the execute, or you can also change the mode something like 700 in a alphanumeric form, that is like 700, that means for user you have all these three permission, that is read, write and execute, whereas for group and other users, they have like zero permissions, they do not have any kind of permissions, right? So you can just do like this. Alright, and similar, this is just terminate with this and you can change, but you guys can try this command by yourself. Alright, okay, now let's clear this and just start beginning this exercise 2, that is just writing your C programs. Okay, so you have to write this particular program in which you have to print out some certain syntax, okay, in this form. That means you have to synchronize by means of signal. So here we will try to see how we can synchronize by using signals. So what you have to do is you have to include standard header files, like input and output files, like these are all the libraries that you have to include, right? So also the library headers are included. Then most important thing, like you have to also include this signal, and then you have to also include the Unix standard header file. Okay, so this is your main function, and okay, so let's begin. Let's declare this all the functions that is required. That is, first what you need is you need a signal handler. Alright, and this is just the declaration. And second, you need a child, and third, you need a father or parent, something like whatever you say, and this all take the PID, the variable PID. Okay, so our goal is just to print out like like I'm parent, I'm child, I'm parent, I'm child. So here it's just synchronize itself, the parent and child will synchronize itself. So how do we do it? Like first you guys have to understand is like this one, just declare the PID variable and it must fork, and immediately you start checking like if it is 0. So when it's 0 it's a child, and else it's a father, right? So when it's a child, it has to just do one thing, that is it has to call this function that is a child function, and this child function has to take this call get this system called the get PID. So it takes this PID, and when it's a father it will just call this father function, and similarly it also take this PID. Alright, so and lastly you return. Okay, before doing this, the most important thing is how shall we install the handler. Then installing the handler is simple. It's just like you check for signal, and the parameters you have to pass is first is the type of the signal, that is these SIG users, there are two kind of signals, okay, that are mostly designed on purpose for the programmers to use in whatever form they want. So SIG user and SIG user 2 are two kind of important signals that can be used by the programmers, okay, and they can be used to signal any kind of signals. So SIG user and signal. So this is the signal handler, that's the parameter that is passed. So if it is not equals to error, SIG error, if it is equals to signal error, then you have to print this particular system, that is fprintf. So that the error in signal handling. Alright, so else what you do is just you return 1. No, inside, like if this happens you print out and you return 1, otherwise then else then this situation is the signal handler is installed in this situation, inside this forking situation, like I fork to create the processes, right, child processes. So this is it, and now what you guys have to do is like you have to extend all these functions that are declared. So what it does, it just returns, and for here what it does is for this child, okay, for this specific child case, what we have to do is while, just loop it while forever true, that means while 1. So what it does is like while true, you have to, for child what he has to do is, and also be careful about this PID. It has to pause itself, it has to sleep for let's say 2 seconds. Pause means it's waiting for the signal, it sleeps for 2 seconds, it perform this task, like it prints out something like standard out, it prints that okay, I am the child, right. Then it sends the signal, that is by using this system called kill, that means it's taking the PID, and what is it doing, just saying that sending this kill is sending the signal to this PID, the process ID, the process with this process ID, that is the parent process, right? Because as you guys can see here, the child's parent process is passes the parameter here. All right. So, and the second is the signal, that is the signal send. And lastly, yeah, it's just, this is it. Lastly, it returns. Now for in the case of parent, it also checks for forever loop, while true forever. And what it does is like it sleeps first for 2 seconds, right? So when it sleeps for 2 seconds, then now it like does its action, that is like perform its action, that is like standard out. Some just prints out that he's a father or something like this, and parent sends the signal, that is the same PID, the child PID, right? Because here the father is in the father function, the PID, that is the child PID, is passed, because fork returns this fork function returns the child PID, because I have already also explained this before, right, in my previous saying. Okay, and lastly okay, now I think it's up to the point. So well, you compile and try to run what it says. Oh, this is the situation here now. Okay, it says that I'm parent, okay, I'm child, I'm parent, okay, and keeps on printing in a loop, and that was our goal to perform these situations, right? Yeah, this is the thing, this is the program we should have performed in such a way that was I'm parent, I'm the child, I'm the parent. So here the synchronization was occurred. So parent and child are synchronized by using the signal. Alright, so just remove this, and we are done with this exercise 2. Now just try with the exercise 3, and what it says is write a C program in which the just like producing the messages, whereas the consumer is consuming the message processed by the producer. So here there are two processes, so they must be synchronized by using this system called signal, right. So the hint was just to use read-write operation plus signals to synchronize, and read-write operations to open the file and read the file, right? And otherwise also you can modify the previous exercise so as to read and write the file, okay, and just use the same signal just to synchronize. Alright, what I have done here is like I have already written a program here that is more related with producer and consumer, and I will just try to show you this. Okay, one need to try to compile and run it. Yes, so whatever I sender sends 3, 4, 5, Yeah, the receiver is receiving 345. So 456 is I sent, 456 is received, 789 is sent, is similar. Okay, so this is the program. All right. Okay, so I have to wait for the signal to respond. Okay, this was all about the situation. Okay, now, okay, let me go through the program. What is the important thing? Everything is same. The synchronization part is same. Okay, like for the child, what is like child means here is a receiver, whereas sender is a parent. So like father. So what has to be done is like a sender, when it sends the signal, it has to send to the okay, look, this is the sender, and it receives the PID, process ID. So it has to receive the PID of the sender receives the PID of the receiver. So it has to send the signal by using uh, system call to send the signal to this uh, receiver PID process, the receiver. Okay, and it has to wait for the lastly, after sending the signal, it has to wait for the signal. It means it has to wait for the receiver to respond or send the signal back. So here the receiver also sends the signal by using the same system call to sender PID, sender process ID. It sends the signal, that is user 1, and similarly just performs the action. So the same action is done here. The action, what it done, it sleeps. Here the receiver, what it does is just sleeps, it performs its action, then it sends the signal. Okay, first it pause, it waits for the signal, second it sleeps, third it performs its action, and lastly after the action is finished, it just sends the signal to the uh, sender, so that now the sender receives the signal, and it also performs the action, right? All the actions here is performed, like sending, like send message, increment, and then it sends the signal to the receiver that I have just performed my action. Look, I have just produced the uh, messages, and then lastly it waits for the receiver to respond. And this is the same way, okay, of solving the problems about producer and consumer. And here you can also check out the all things are same. Okay, here the catcher is the signal handler. Okay, this catcher, and it's just returning. And similarly you can also see that there are, you fork, and there is the child, there is a receiver, and else you also again fork, you create another process, that is a sender inside the parent. Alright, then lastly this main process, okay, has to wait for both the sender and receiver to change the status, because here we are also using the wait system call to synchronize, and everything is all same. Okay, the only thing that you guys have to understand is like you have to scan the input, like scan the message, right? You have to scan the message, you have to just write the message, like here is like file pointer, you write it to a file that is given by this name. The name is already here defined as a temporary text. Okay, you write this file, check for null pointer, and then you say that you increment the message, that means you have sent the message. And similarly here the receiver reads the file that the writer has the sender has sent. And similarly, after performing all this action, scans the file, and just then also it says that the received messages are implemented. And this is the simple way. Alright, so this was all about our session, and I hope you guys understood about how find command works. And I also hope that you guys have understood the difference between registering a signal handler and sending a signal to a process. And because there are two tasks, right? Because I first registered the signal handler, and then I use the kill process, system call, to send a signal to the process, to the particular process with the specific PID, right? And finally, you also know how to synchronize the process using signals, right? So this is all about our session. Thanks for listening, and hope to continue in the new session. Okay.